Welcome to today's Explainer. I am absolutely thrilled to guide you through this one because we're looking at a truly fascinating concept: finding massive inspiration for success in the most unexpected, microscopic places. You know, we spend so much time looking up at the towering figures of history or the giants of the natural world for guidance. But today, we're looking down. We are going to explore how complex systems, operating completely silently right beneath our feet, can fundamentally change the way we approach our own human challenges.
Think about this for just a second. Can a creature the exact size of your fingertip actually teach you how to be successful? It kind of sounds counterintuitive, right? We're so conditioned to associate physical size with power, capability, and complexity. But the stark contrast between their tiny physical footprint and the massive impact of the lessons they offer is exactly what makes this whole topic so incredibly captivating. As you'll see, some of the most profound organizational blueprints don't require massive stature. In fact, true efficiency often scales down perfectly.
Okay, let's dive into this. When we consider impressive, highly capable animals, our minds naturally jump right to the heavyweights of the ecosystem. We think of lions dominating the savanna through sheer force, elephants showing off vast emotional intelligence, or whales navigating the deep oceans with complex sonar. We inherently look for grand scale. But honestly, some of the most fascinating stories and profound structural lessons in all of zoology come from miniature marvels. We're talking about creatures that comfortably fit right on the tip of your finger, yet operate decentralized networks and display a collective intelligence that literally rivals the most advanced human supercomputers. The focus shifts entirely from the power of the isolated individual to the unmatched power of the collective.
Take the humble ant. A team of ants can seamlessly work together to carry a crumb that is many times their own size and weight. Individually, one ant couldn't even budge the thing. But together, they become this unstoppable powerhouse executing a highly coordinated logistical operation. I mean, think about the physics of that for a second. If humans were scaled to this exact biological ratio, it would be like a small group of friends effortlessly carrying a commercial airplane down the street. It's wild. And it's not just about raw physical strength. It's about perfect weight distribution, real-time spatial awareness, and a unified drive to achieve a singular objective without a single central commander barking orders. It's a masterclass in dynamic, real-world problem-solving.
The well-organized ant city.
So just like any bustling human metropolis, the ant city runs on specialized, highly evolved civic roles. But unlike human cities, there's no gridlock, no bureaucratic red tape, and zero overlapping egos. Every single ant has a crucial, very specific job that keeps the entire ecosystem running flawlessly. First, you have the workers. They're out there acting as the ultimate supply chain logistics experts, gathering food and keeping resources flowing. Then you have the soldiers, whose sole purpose is to establish perimeters and defend the colony from immense existential threats. And of course, the queen, who acts as the biological engine, ensuring the survival of future generations. What's so remarkable here is the biological programming that dictates these roles. There's no confusion, no hesitation. It's a perfect, self-sustaining society that thrives purely on individual dedication to the greater good of the whole. When you compare that to the daily struggles of human organizational management, their total lack of ego is deeply humbling.
Now, what's really interesting about this slide is how, despite their tiny size and relatively simple brains, these ants operate with remarkable algorithmic efficiency through three sequential actions. First, they communicate, but they don't do this through sound. They use chemical signals called pheromones. As they walk, they leave these invisible chemical trails that essentially map out their environment, creating a dynamic, real-time GPS system for the rest of the colony to read and follow. Second, they cooperate. Once a goal is established, like retrieving a major food source, they work in flawless unison, reading those chemical maps to find the absolute optimal route. And third, they solve problems together in real time. If a flood washes away a path or a massive obstacle blocks their route, they don't retreat or wait for management to draft a new plan. They literally build living bridges out of their own interlocking bodies to span gaps and overcome the environment. It is rapid, decentralized innovation at its finest.
Section 2. Teamwork and Communication.
Scientists aren't studying ants just to understand basic animal behavior. They study them because these tiny insects provide an incredible battle-tested blueprint for human success. By observing them, scientists and systems engineers learn incredibly valuable lessons about teamwork, communication, and social organization. Just consider the real-world applications for a moment. Global corporations trying to optimize massive supply chains, sports teams running complex multivariable plays, or even governments attempting to organize efficient city grids and traffic flows. All of these complex human endeavors are basically striving for the exact kind of seamless, decentralized coordination that ants naturally execute every single day. They have spent millions of years perfecting the ultimate algorithms for collective success, and we are just now catching up by studying their movements.
Section 3. Rethinking Zoology.
So the crucial point is how we actually define what we're studying here. Zoology is not just the study of animals. If we leave our definition at that simplistic level, we completely miss the magic of the science. Zoology is vastly more encompassing. It's the deeply intricate study of life itself. It is the study of adaptation, of complex survival strategies against impossible odds, and of the incredible, awe-inspiring diversity of nature. When we look at the ant, we aren't just looking at a bug on the sidewalk. We're witnessing millions of years of brilliant evolutionary adaptation unfolding right before our eyes. Shifting your perspective to see this macro-level brilliance in micro-level creatures fundamentally changes how you view the natural world around you. Suddenly, the dirt beneath your feet isn't just soil. It's a thriving, highly optimized civilization.
I want to leave you with this powerful thought directly from our source today. Quote, "The next time you see an ant carrying a crumb many times its own weight, remember, even the smallest creatures can inspire great ideas." End quote. It's a brilliant reminder to just keep our eyes wide open. Inspiration and profound life lessons aren't exclusively found in thick academic textbooks, corporate seminars, or on giant global stages. Some of the most intricate and brilliant strategies are playing out right down there in the everyday undergrowth, just waiting for us to slow down, look closely, and pay attention.
Now, I want to hear from you. Have you ever observed an animal, whether it's a massive mammal or a microscopic insect, doing something deeply surprising, intelligent, or highly coordinated? Think about those quiet moments where nature completely stopped you in your tracks and made you rethink what was actually possible. I highly encourage you to share your own observations and experiences in the comments below. Let's keep this fascinating conversation going. Thank you so much for joining me for this explainer, and I will see you next time.